Good morning, it's Dr. Huang again. Today, I'm going to teach you how to assign oxidation numbers to atoms. First, let's go over the rules. There are a total of 8 rules to assign oxidation numbers to atoms. Rule number 1. The oxidation number of an atom is 0 for all neutral substances that contain only one element. Rule number 2. The oxidation number of an atom in simple ions is equal to the charge of the ion. Remember, simple ions only contain one atom. Rule number 3. The oxidation number of hydrogen is +1 when combined with a nonmetal or nonmetals. The oxidation number of hydrogen is -1 when combined with a metal or metals. Rule number 4. The oxidation numbers of group 1A and 2A metal atoms in a compound or ion are +1 and +2 respectively. Let's look at the periodic table. For the first column except hydrogen, from lithium to francium are called group 1A metals. We also call them alkali metals. When alkali metals form a compound or ion, the oxidation number of alkali metal atom will be +1. The second column is called alkaline earth metals. We also call them group 2A metals. When group 2A metals or alkaline earth metal atoms form a compound with the other elements or form an ion either by themselves or with the other elements, the oxidation number of alkaline metal atoms will be +2. Rule number 5. The oxidation number of oxygen atom is -2 unless in O2, O3, H2O2, and O2 2-, because both O2 and O3 are elements. Therefore, based on rule number 1, the oxidation number of oxygen atom in both O2 and O3 should be 0. I'm going to explain how to get the oxidation number of oxygen atom in both H2O2 and O2 2- after we learn rule number 7 and rule number 8. Rule number 6, the oxidation number of fluorine is -1 in a compound or ion. The oxidation number of other halogen atoms is -1 except with oxygen or with other halogens. Let's look at the periodic table again. This group is called halogens. When one halogen combines with another halogen, we have to determine which halogen is more electronegative. When we go up, the electronegativity also goes up. Therefore, in terms of electronegativity, fluorine is more electronegative than chlorine. Chlorine is more electronegative than bromine. Bromine is more electronegative than iodine. Iodine is more electronegative than acetylene. When one halogen atom combines with a different halogen atom, the more electronegative one will have oxidation number of -1. Then we can use the equation based on rule number 7 or rule number 8 to calculate the oxidation number of the other halogen. I will use an example to explain how to do that. Rule number 7. The sum of the oxidation numbers of all atoms in a neutral substance is equal to 0. Rule number 8. The sum of the oxidation numbers of all atoms in a polyatomic ion is equal to the charge of the ion. From rule number 7 or rule number 8, we can set up an equation. Using rule number 1 to rule number 6, we can determine the oxidation number of at least one atom. We can solve the equation from rule number 7 or rule number 8. Then we can get the oxidation number of the atoms that we cannot use rule number 1 to rule number 6 to determine.